Since the conservation of energy and conservation of angular momentum is disobeyed in beta particle decay, since the conservation of energy and angular momentum is not obeyed in beta decay, so it led to the emission of some unknown particle along with beta particle. Pauli put a hypothesis that there must be the emission of particle with beta particle this new particle should have zero charge and zero rest mass. He named this particle as neutrino. This particle as neutrino. Neutron means just like neutron. This is not the neutron, but just like the neutron does not have the charge, so the nil charge is there. So because of that, this particle should also be named in the like way. That this must be the neutrino, which has the zero charge and the zero rest mass. At the time of beta decay, there is conversion of nucleons as follows. And I told you that the nucleus which are proton rich, in that the proton is converted into neutron, and the nucleus which are neutron rich, the neutron is converted into the proton. H11, this is the proton, then this is I will take first neutron, N01, H11 plus E minus 1 0 plus antineutrino. This is neutron, this is proton, this is beta minus particle, this is the antineutrino. Neutron, proton, beta minus particle, and this is antineutrino. Similarly, when this H11, the proton converts into neutron, then this is your beta plus 1 0 plus neutrino. So this is proton, this is neutron, and this is the beta plus particle, and this is neutrino. It means that neutrino is emitted with the beta plus particle and antineutrino is emitted with beta minus particle. Thus, neutrino and entry neutrino particles are emitted with beta plus particle and beta minus particle respectively. And this particle is shares the kinetic energy of the beta particle. The neutrino shares the kinetic energy of beta particle. Initially, the beta particle has maximum energy and neutrino has zero energy. The beta particle imparts its kinetic energy to neutrino. So the energy of beta particle decreases. And energy of neutrino increases. As a result, the beta particle carries 2/3 of maximum energy and 1/3 of maximum energy is carried by neutrino. It explains that energy is not violated, conservation of energy is not violated. Thus, conservation of energy holds good in beta decay. If we see the angular momentum, angular momentum of neutrino is equal to plus minus 1 by 2 h upon 2 pi. H, the Planck's constant. Planck's constant. Now we can see that this conservation of angular momentum is also followed. Like this, suppose we have this n01, this converts in h11 plus e minus 10 plus anti-neutrino. So this 1 by 2 plus minus 1 by 2 h upon 2 pi, and this is plus minus 1 by 2 h upon 2 pi, this is 1 by 2 h upon 2 pi, and this is plus minus 1 by 2 h upon 2 pi. So now you can see that if we neglect this particle suppose is not emitted, then what will happen that this angular momentum will be either 0 or 1. If they are in same direction, then this will be 1. If they are anti-parallel to each other, or if they have positive and negative sign together, then this momentum will be 0. And now this says that this reaction should hold that it has so much angular momentum. So by assuming this one, we can see that if this is supposed to be 0, even the angular momentum of this particle is equal to so much. So angular momentum of this one must be the integral multiple of 1 by 2 h upon 2 pi. Then this angular momentum law, conservation of angular momentum is hold good. Similarly, if suppose we have this h11, this will be your n01 plus e plus 10 plus neutrino. Then this is 1 by 2 plus minus 1 by 2 h upon 2 pi. This is 1 by 2 plus minus h upon 2 pi. This is 1 by 2 h upon 2 pi, and this is plus minus 1 by 2 h upon 2 pi. So in both the cases, when the beta plus or beta minus particle are emitted, then the law of conservation of angular momentum holds good. It shows that conservation of angular momentum is followed in beta decay. Thus, the neutrino particle, the hypothesis given by Pauli was found to be correct, that there must be the emission of the neutrino. Neutrino and antineutrino are the antiparticle of each other. Neutrino and antineutrino are antiparticles. So it is that when beta minus particle is emitted, then there is emission of antineutrino. When beta plus particle is emitted, there is the emission of neutrino. Thus, this is very fruitful, that the hypothesis of Pauli, that the law of conservation of energy and the angular momentum are followed, which were supposed to be violated during the beta emission. And moreover, if you can see the properties of neutrino, then neutrino have zero mass and at the rest, and it has the angular momentum plus minus h 1 by 2 h upon 2 pi, and the this neutrino shares the energy of the beta particle with the during the emission of electron or the positron. So properties of neutrino. Number one, it has zero rest mass. It is a neutral particle. Neutral particle. And third, its angular momentum is plus minus 1 by 2 h upon 2 pi. So this this does not pre-exist in the nucleus. It does not pre-exist in it is formed at the time it is formed along with beta particles. So these are the properties of neutrino. So this is about that how this law of conservation of energy and angular momentum are held in beta decay. So you just like, share and subscribe this video.